All right, let's start by going through this review with number 6 here. It says determine the quotient remainder when 3x to the fourth minus 7x cubed plus 3x squared minus x minus 2 is divided by x plus 2. Now the first thing I want to look for is I want to make sure that every term is represented. So if our degree is 4, we have 4, 3, 2, 1, and then none. So I know that every term is represented, so I don't need to hold a position with like a 0 or anything like that. So let's just jump right into how to divide this. Now I'm not going to do long division. I'm going to use synthetic division. Remember with synthetic division, we look to see what we're dividing by and identify the 0. And we're dividing by x plus 2, so the 0 here would be negative 2. So I'm going to put a negative 2 out in front. I'm going to put this long box here, and this is where I'm going to put the coefficients. So we would have 3, then negative 7, then a positive 3, then a negative 1, and a negative 2. And then in this last spot down here, if we have a remainder, that's where the remainder will go. So remember the process is bring down the first term. The first term is 3. Then I take negative 2 times 3. Negative 2 times 3 is negative 6. And next we would add these two terms together. Well, negative 7 plus negative 6 is negative 13. And we're going to go through that same process now again. We're just going to repeat it. So negative 2 times negative 13 would be a positive 26. Now we add those two terms, we get 29. So again, we repeat the process. Negative 2 times 29 would be negative 58. And negative 58 plus negative 1 would be negative 59. And lastly, we're going to take now 2 times negative 59. And when you do that, you get negative 118. And so that means that when we go to add these two together, that's going to be our remainder. And when we do that, you get negative 120. So now, the way that we come up with what our answer is going to be, remember this term stays as a constant. So we don't do anything with that because it's the closest to your remainder. Then after that, we would have an x, and then we'd have x squared, and then we'd have x cubed. So our answer for that would be 3x cubed minus 13x squared plus 29x minus 59. And the way that we write the remainder is we would say either the remainder is negative 120 or we would write it as plus negative 120 over what we divided by originally, which was x plus 2. So that's how you do number 6. All right, let's look at number 9. Number 9, it says, by what complex number would you multiply 2 minus 3i over 3 plus 2i to write the fraction in a plus bi form? Well, we just multiply by the conjugate. That would be 3, the conjugate of the denominator, which would be 3 minus 2i. So remember, the first term, the 3 stays the same. Then what we do for the second term is we do the opposite of what's in between there. So that's the conjugate. So the conjugate would be 3 minus 2i. All right, now let's actually do the simplifying here. So we have, whoops, let me switch to a pen here. So we have 2 minus 3i is what's in our numerator. Our denominator, we have 3 plus 2i. So what we're going to do is we're going to multiply by the conjugate. The conjugate of our denominator we said is 3 minus 2i. Remember, there's 3 different ways that we could, let's do the denominator first. There's 3 different ways we could do the denominator. One way is to use that box method, which I'm going to do in a little bit when I multiply 2 minus 3i times 3 minus 2i. So that'd be one way. That would take a little longer, though. Remember, there's a couple of shortcuts we could use. The first shortcut would be just to remember that when we use that box method, the middle terms would be the ones that would cancel out. So we'd be left with just multiplying the first terms and the last terms. So 3 times 3 is 9, and 2i times negative 2i is negative 4i squared. But remember, I squared is negative 1, so this would be the same as 9 plus 13. Okay, now that's one of our, remember I said there's 3 different ways we could get our answer. The other way we could get our answer is to remember that we could use that trick of just squaring whatever the first term is and squaring without the 2, or without the I, just squaring basically the coefficient, the 2 there, and add those together. So 3 squared would be 9, 2 squared is 4, and 9 plus 4 is 13. And that trick will also work. Again, you don't focus on the sign in between there. It doesn't matter if it's 3 minus 2i, we would still take 3 squared plus 2 squared. Okay, so it's always just the numbers there, and you add them together. All right, let's look at the numerator, though. So the numerator, 2 minus 3i times 3 minus 2i, I'm going to use that box method. All right, so when we multiply those together, we would get 3 times 2 is 6. 3 times negative 3i is negative 9i. And 2i times 2 would be negative 4i. And negative 2i times negative 3i would be a positive 6i squared. But remember, I squared is negative 1, so this really means that we have negative 1 times 6, which is negative 6. All right, well, 6 minus 6 is 0, and negative 4i minus 9i would be negative 13i. Oh, well, watch what happens. We can simplify this. The 13s would cancel out, leaving us with just negative I. So 2 minus 3i over 3 plus 2i simplifies to just be negative 1i, or negative I. If you said 0 minus I, that's the same thing. All right, let's look at number 10. Number 10, it says k is 2 plus 4i and w is 3 plus 7i. We're going to find each of the following. So first off, we want to take 2 times k plus w. So we would have 2 times what k is, which is 2 plus 4i, plus what w is, which is 3 plus 7i. Well, I'm going to start by distributing the 2 through. So we would have 2 times 2 is 4, plus 2 times 4i is 8i. So we'd have 4 plus 8i, plus 3 plus 7i. Now we're going to combine like terms. We want to put it in a plus bi form. So we want just the constants, the numbers without an i. We want those to stay the same, or to start first. So we'd add 4 plus 3, and 4 plus 3 is 7. We're done with those. 8i plus 7i, that would be 15i. So that'd be your answer in a plus bi form. Next, with k times w, I'm just going to jump right into the box here. So let's start by drawing the box, and then we're going to put a on the or k on the outside, or k and w on the outside here. So k, it doesn't matter where we put it, it'd be 2 plus 4i. And the w, I'll put over here then, would be 3 plus 7i. So we multiply these together. 3 times 2 is 6. 3 times 4i is 12i. Bottom row, 7i times 2 is 14i. 7i times 4i would be 28i squared. But remember, I squared is negative 1, so this would be negative 28. So when we combine like terms, we would start by adding these two together. So 6 plus negative 28 would be negative 22. And then we would add together these two terms. 14i plus 12i would be 26i. So we just have negative 22 plus 26i. This would be your answer for part B. All right, let's look at number 13. This is a factoring problem that asks us to factor. This has got 4 terms in it. This is one of the last things we learned about. Remember, there's 4 terms. We're going to group together the first 2 terms and the last 2 terms. So in the first 2 terms, I look for the greatest common factor. I see that both of those are divisible by 9. I also see that they both have a b, so I'm going to factor out a 9b. That would leave me with a plus 2. Now, in the second set, I see that the greatest common factor there is a positive 5, so I'm going to write it as plus 5. And that would leave me, when I factor that out, a plus 2 as well. So what I recognize is that both, whoops, let me highlight there. Well, first off, if I look at this as being one term and this being a second term, between those 2 terms, we have a plus 2 is the same in both of those. So I'm going to factor out a plus 2. That leaves me with 9b plus 5. Now, before we say we're done, we want to always look to see, can that be factored any further? It can't be, so that is my final answer for number 13. All right, for number 14, we want to use the sum and differences of cubes theorem. Well, this would be the sum of 2 cubes. So I want to look to see, well, first off, can we factor anything out? All right, so I see that 64 would be divisible by 2, but 27 isn't. 27 is divisible by 3, but 64 isn't. So there really isn't, I mean, as you go through the numbers, there's nothing that's going to work. There's no greatest common factor here. So what I can do, though, is I want to figure out what would I cube that would give me 64m to the 6th. And what would I cube to get 27k cubed? Let's start with the 64. 4 cubed would be 64, because 4 times 4 is 16, and 16 times 4 would be 64. Now with the m, it's a little trickier here because I want to figure out what would I multiply. Because remember, when we have a power raised to a power, we multiply those two powers together. So I need to think about what would I multiply 3 by to get 6? Well, that would be 2. So 4m squared, if you were to cube that, would give you 64m to the 6th. Well, now I want to figure out what would I cube to get 27k cubed. Let's start with 27. Well, 3 cubed would be 27, because 3 times 3 is 9, and 9 times 3 is 27. And when you cube k, you would get k cubed. So now we've broken that down, okay? Because 3k, when you cube that, would give you 27k cubed. All right, well, how does this help me? Well, remember we have our rule. When we have a cubed plus b cubed, that factors down to be a plus b, and then we would square whatever a is, then it would be minus a times b plus b squared. And the way that we get our signs here is with that SOAP acronym. So we'd have the same sign, then the opposite sign, then always positive. So let's apply that rule now to this problem. So this would be our a, and this would be our b. So we would have a plus b. So this would be 4m squared plus 3k would be our a plus b. And then we're going to square whatever a is. A is the entire 4m squared. Well, when I square 4, I get 16. And when I square, let me just show you up here. So when we square the 4, we get 16. Now when we multiply, or when we square the m squared, remember we're going to multiply those two exponents. So we would have m to the 4th. That'll be minus, and then we're going to have a and b multiplied together. So I'm going to take 4 times 3 and get 12, and then m squared times k would just be m squared k. And next we would have plus, then we're going to square the b. The b is 3k. So when I square 3, when I square 3k, well, I would get 3 squared is 9, and then k squared. So this entire piece would be your answer. So that's a big one. All right, so let's look at 9 and 10. So we want to determine whether we have a polynomial that can be represented that's got less than a degree of 5. And so when you're doing these problems, remember, I would highly recommend using a calculator. So when we're even some of them that might be simpler, okay, just because you don't want to make any little mistakes. So what we're going to do is we're going to find each of these differences to see if it is and if it is, right off the bat, if they're all the same, then we know it's a first degree polynomial. If I take 82 minus 59, I get 23 is my answer. And if I take 59 minus 40, well, that's going to be 19. And 40 minus 25, well, that would be 15. 25 minus 14 would be 11. 14 minus 7 would be 7. And 7 minus 4 would be 3. So I could see here, since they're not the same, that it's not a first degree polynomial. So now I have to do this again. By the way, if you're wondering, well, what does this sentence here mean? It's going to be degree less than 5. Well, that just means if we get to the 5th set of differences and they're not the same, you can stop. You don't have to keep going. You could just say that it's not a degree polynomial less than 5. All right, so now I'm going to do these. So with my second set of differences, 23 minus 19, that would be 4. 19 minus 15, guess what? That's 4. 15 minus 11 is 4. 11 minus 7 is 4. And 7 minus 3 is 4. So the fact that all three of these are the same difference, and it's a second set of differences, means that this is a second degree polynomial. That would give you all of those values. All right, let's look at the next one. Okay, so for the next one, we're going to take 138. We're going to start with 138 minus, whoops, let me draw my lines here. I like drawing these lines just because it gives me a visual to see what I'm subtracting each time. All right, well, 138 minus 101, so that's going to be 37. And if I take 101 minus 70, well, that's 31. If I take 70 minus 45, that's 25. If I take 45 minus 26, well, that's going to be 19. And if I take 26 minus 13, well, that's 13. And 13 minus 6, well, that's going to be 7. All right, so I can see here that it's not a first degree polynomial. So let's do the next one. So if I take 37 minus 31, that's 6. 31 minus 25 is 6. 25 minus 19 is 6. 19 minus 13 is 6. And 13 minus 7 is 6. So the fact that these are all 6s, this is my second set of differences, means that just like the first one there, this one is also a second degree polynomial. This is where, again, making sure that you subtract correctly each time, because if you make one little mistake with your subtraction, it'll throw off your whole answer and you'll get the wrong answer. Okay, let's look at number 12 here. We're going to divide these polynomials. Now I am not going to use long division. It's just way more complicated. I'm going to use synthetic division. Remember with synthetic division, we start with this and we just look to see, well, what's the 0 of what we're dividing by? The 0 there would just be 1. Before I start putting numbers in here, I want to make sure that every one is represented. So I have 4, 3, 2, 1, and none. So that means that every one's represented, so I don't have to put in a 0 or anything like that. I can just jump right in here to putting down these coefficients. So coefficients would be, use a pen here, 3, 5, -2, 1, and -7. And down here below the -7, I'm going to put a box for if I have a remainder. Okay, so I'm going to bring down the 3. That's my first step. 1 times 3 is 3. So I'm going to add those together. 5 plus 3 is 8. So I'm going to repeat that same process now. So 1 times 8 is 8. -2 plus 8 is 6. 1 times 6 is 6. 1 plus 6 is 7. 1 times 7 is 7. -7 plus 7 is 0. So this one would not have a remainder. So then we just have to put in our values for x. Remember what happens closest to the remainder? That stays a number. So this will be an x. This will be an x squared. This will be an x cubed. So we would say our answer is 3x cubed plus, don't forget the plus in there, 8x squared plus 6x plus 7. All right, let's look at number 13 now. So 13, I'm going to do the same way. I'm going to do this with synthetic division. So we start with the x minus 3, and the 0 there would be a positive 3. And then we look at our numbers here, make sure that every term is represented, and we do. We have 4, 3, 2, 1, and none. So I'm going to put my coefficients down now. The coefficients would be 1, -1, -2, positive 2, and -42. And then we put our box for remainder down below. Okay, so bring down the 1. So 3 times 1 is 3. Then we add those together. -1 plus 3 is 2. 3 times 2 is 6. -2 plus 6 is 4. 3 times 4 is 12. And 12 plus 2 is 14. 3 times 14 is 42. And 42 plus -42 would be 0. So this one does not have a remainder either. So now what we're going to do is we're going to put our variables in here. So remember the 14 will stay at 14. This would be the first one, then going from right to left will be x, then x squared, then x cubed. So your answer would be 1x cubed, or just x cubed, plus 2x squared, so don't forget to put your pluses in here, plus 4x plus 14. That would be your final answer. All right, so in number 19, this one says, since x plus the square root of 5 would be a factor of that polynomial, what would be another solution to the same polynomial? Or actually, no, they're not asking that. They're asking for if x plus square root of 5 is a factor, what is going to be a solution to that? Well, remember, using that factor theorem is whatever a factor is, its 0 would be the solution. And so that means if we were to set x plus square root of 5 equal to 0 and solve it, you would get negative square root of 5. So negative square root of 5 would be a solution to that equation. All right, let's look at number 22. For 22, we're going to use, this would be using the chunking method. Now, this is not going to be a major emphasis, but I do want to make sure that you understand. I've seen this a couple of times now. But what we're going to do is we're going to say that a, the value for a is going to be x squared minus 3x, because that's what we have in parentheses there. So I'm going to say, instead of x squared minus 3x, now I'm going to say a squared minus 2a minus 8. And I'm going to factor that down. Okay, so I'm going to look to see what two numbers multiply together to be -8, that add together to be -2. So put a here and a here. So the two numbers that multiply together to be negative 8, that add together to be negative 2, would be negative 4 and positive 2. Because negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. Now that can't factor anymore yet, because I'm gotten as far as I could go. But now I'm going to take and substitute that back in anytime I had an a. So we would look at this as being x squared minus 3x minus 4 times x squared minus 3x plus 2. Whoops. All right. So now we can't just say we're finished with this either. I need to look to see, can I factor this down, this first term, any further? Or the first set of parentheses any further. So I want to look to see, is there any two numbers that multiply together to be negative 4, that add together to be negative 3? And that would be x minus 4 and x plus 1, because negative 4 times 1 is negative 4, and negative 4 plus 1 would be negative 3. Now let's look at the x squared minus 3x plus 2. Are there any two numbers that multiply together to be a positive 2, that add together to be a negative 3? And that would be negative 2 and negative 1, because negative 2 times negative 1 is a positive 2, and negative 2 plus negative 1 is negative 3. So that would be your answer after factoring all that down. All right, so here's some more factoring. Let's look at this first one. So this first one here has got 4 terms, so we're going to factor this one by grouping. Got to remember with grouping that, notice what I did there with my second set of parentheses. I put that minus inside the parentheses there. Don't put it on the outside, put it on the inside. All right, so that first set of parentheses, I look for my greatest common factor, would be x squared. So that would leave me with x cubed plus 1. In the second set of parentheses, since the first term is negative, I want to factor out a negative. And I see they're both divisible by 6. So factor out a negative 6. So when you do that, negative 6x cubed divided by negative 6 would be a positive x cubed. And negative 6 divided by negative 6 would be a positive 1. So what we want to do is we want to look at this as being two separate terms. And both of those terms have x cubed plus 1 as your common factor there. And then we would have x squared minus 6 left over. Now when it says factor it with real coefficients, I want to look to see, can this factor down any further? And let's start with the x squared minus 6. X squared minus 6 cannot be factored further with real coefficients because, oh, I guess we can with real coefficients, sorry. So that would just factor down to, because we could take the square root of 6 and just say it's a square root of 6. So we're going to, I'm going to actually start with that piece first. And so this one would factor down to be x plus square root of 6 times x minus the square root of 6. Now let's look at the x cubed plus 1. That is a sum of two cubes. So that would factor down to be x plus 1 times x squared. And then we'd multiply our a and b, or x and 1 together, to just get, whoops, it'd be opposite sign here. It'd be minus 1x, or just x. And then it'll be plus, always positive. And then we square the 1, we get 1. So that would be your final answer after factoring 23 down completely. Let's look at 24. So 24 is a little easier. That's just a difference of two cubes. And you would cube t to get t cubed, and you'd cube 3 to get 27. So this would factor down to be, use a different color here. So we would use t, and then it would be minus 3. We'd have t squared, and we multiply those two together, so it'd be, and then it'd be always positive, so it'd be plus 3t. Or, I'm sorry, it'd be opposite sign and then always positive, but it'd be plus 3t. And then always positive, so plus, now we square the 3. 3 squared would just be 9. And that can't factor any further, so that would be your final answer for 24. For 25, this is another one where we have a set of 4 terms here. So I'm going to do this by grouping. So we're going to group together the first 2 terms and the last 2 terms. Again, make sure that minus that's in the third term there, that gets put inside the parentheses. All right, so we would have x to the 4th that we'd factor out from the first 2 terms, leaving us with x plus 2. The second set of terms, we just have the minus that we would have first, so we're just going to have this as minus 1. And then that would leave us, when we divide by negative 1, we'd be left with x plus 2. So you should notice here that in the first set and the second set, we have an x plus 2 in common there. So I would factor out an x plus 2. That would leave us with x to the 4th minus 1. Now x to the fourth minus 1 is a difference of squares. Now the x plus 2, I can't do anything with that. But this would factor down to be x squared plus 1 times x squared minus 1. And guess what? X squared minus 1 is also a difference of squares. So that would factor down one step further to be, so the x plus 2 stays the same, the x squared plus 1 stays the same, x squared minus 1 factors down to be x plus 1, x minus 1. So you always need to make sure that you have it factored completely before you say you're finished. All right, let's look at number 28 here. So 28, we have m is 7 plus 3i and n is 11 minus 8i. So I'm just going to replace m with 7 plus 3i. I'm going to replace n with 11 minus 8i. So first up, I'm going to distribute the 3 through, so that would be 33 minus 24i. Now I'm going to combine like terms. Well, 7 plus 33 would be 40. And 3i, take away 24i, that's negative 21i. So that'd be your answer for 28. For 29, we have m minus n. So for m, we have 7 plus 3i. But the minus, we're going to have to distribute that through. So we minus the quantity 11 minus 8i. So again, the 7 plus 3i, we don't do anything with that, but I distribute the negative through, so it'll be negative 11 plus 8i. Now let's combine like terms. 7 minus 11 is negative 4. And 3i plus 8i would be 11i. All right, let's look at number 30. So number 30, we have n squared. So it's going to be 11 minus 8i. That's going to get squared. Minus 2 times m. m is 7 plus 3i. Okay, now 11 minus 8i squared, that means you don't just square the 11 and square the 8i. Remember, that means that you have to multiply it times itself. So I'm going to use this box method to make it a little bit easier, a little bit more organized. So 11 times 11 is 121. 11 times negative 8 would be negative 88i. And negative 8 times 11 is also negative 88i. And then negative 8 times negative 8 is a positive 64. But we would have 64i squared. Now, I squared, remember, is negative 1. So that 64 really is negative 64. All right, now we're going to combine like terms. So 121 minus 64, well, that's 57. So this will be 57. And then negative 88 plus negative 88 would be negative 176i. And now for the next set, I'm just going to distribute the 2 through. So that'll be minus 14 minus 6i. Well, let's combine like terms. So we'd have 57 minus 14. When you subtract those, you get 43. So we'd have 43 and negative 176 minus 6i. Well, that's going to be 182. That'd be, whoops, minus 182i. And that would be your final answer. So the key there is, remember, when you square something, you don't just square each term. You multiply both those terms by itself. So you need to use that box method to make sure you get the right answer. All right, with 31. With 31, we have m times n. Well, m is 7 plus 3i. And n is 11 minus 8i. And all that's divided by 3. Now, since we have just a 3 in the denominator, we don't have to worry about multiplying by the conjugate. All we're going to do is we're going to start by multiplying the 7 plus 3i times 11 minus 8i. So I'm going to use this box method again. Multiply those together. So 7 times 11 is 77. 11 times 3i, that would be 33i. Negative 8i times 7 would be negative 56i. And negative 8i times 3 would be negative 24i squared. But remember, I squared is the same as negative 1. So this would be the 6. So negative 24i squared would be a positive 24. All right, so now we're going to add these together. So when I take 77 plus 24, I get 101. So in our numerator, we would have 101. And now we're going to combine the 33 minus the 56i. And 33 minus 56i is negative 23i. And all that is divided by 3. Now, I believe our notes, I believe it up here, it says to write your answer in a plus bi form. So what we want to do is you want to break this apart into two pieces. So you'd have 101 divided by 3, and then plus a negative, or you could say minus 23i divided by 3. Now, neither of those are divisible by 3, so we could just leave it like that. That would be your final answer for 31. All right, let's look at 34 and 35. With 34, this one, since we're dividing here, let me just rewrite this. We would multiply a member by the conjugate of the denominator. So the denominator, we have 4 plus 7i. So we don't care about the numerator so much as we do about the denominator. So we're going to multiply by the conjugate, which would be 4 minus 7i. Now we do multiply the numerator by that conjugate. And we'll get to that in just a minute. Now remember, there's 3 ways we could, let's start with the denominator. There's 3 ways we could get our answer for the denominator. The first would be the longest way, and that would be using that box method, which we're going to use in the numerator, so I'll show you that in just a minute. But the other 2 ways are a little easier. One way would be to remember that, well, if we multiply these together, since we're multiplying by the conjugate, the middle terms would cancel out. So all we care about is the first terms. 4 times 4 is 16, and 7i times negative 7i would be negative 49i squared. Now, since I squared is negative 1, remember this would be the same as 16 plus 49. And 16 plus 49 would be 65. So that would be your denominator. Now remember I said that there's 3 ways. This was the second way. The third way is to simply just take whatever the terms are and square them and add them together. Don't worry about the signs. You always add them together. So we would just take 4 squared plus 7 squared. And 4 squared plus 7 squared would be 16 plus 49, which also gives you 65. So those are the 3 ways that we could do it. So let's look at the numerator. So remember, the third way that we could have done that denominator, or the way that we're going to do the numerator, is by using that box method. So I'm going to do that down here. So we would put 29 plus 2i in one spot and 4 minus 7i in the other spot. So now if I take 4 times 29, we get 116. Then we take 4 times 2i and I get 8i. Now negative 7i times 29 would be negative 203i. And then we would have negative 7i times 2i is negative 14i squared. Now negative 14i squared, remember I squared is negative 1. So negative 14 times negative 1 would be a positive 14. So now let's combine like terms. 116 plus 114 would be 130. Then we'd have negative 203 plus 8i. That's going to be negative 195i. Now it says we want to put this in a plus bi form. So the next step I'm going to do is I'm going to break this apart into 2 fractions. So we'd have 130 divided by 65 here minus 195i divided by 65. Now since both of these terms end in either a 0 or 5, I know that both of them are divisible by 5. So I'm going to take 130 divided by 5, and when I do that we get 26. And then we would take 65, we'd also divide that by 5 and get 13. Now I can see that, oh, well, 26 divided by 13 would be 2, so I'm just going to simplify this even further to say 2. Let's see what happens with the 195 and the 65. So 195 divided by 5 would be 39. So we have 39 divided by 13, because 65 divided by 5 would be 13. Well, you might recognize that 39 divided by 13 would be 3. So we'd have 2 minus 3i would be your answer for the first one. So that's your answer for number 34. Let's look at 35. So with 35, let's just do this. I'm going to erase everything here. All right, now that I have all that gone, let's look at 35. So 35, I notice that we have 6 minus I in the numerator, but do you notice something as I'm writing this down? Do you notice something about the denominator? The denominator, we don't have it in a plus bi form. You always want to have it in that form because that'll make it easier for finding the conjugate. Now that's a negative 3 and a positive 2i. All right, so now when you go to multiply by the conjugate would be negative 3 minus 2i. So the 3 would be a negative, but the 2i would change to be the opposite of what it is. All right, so now let's multiply these together. Remember, there's three ways we can multiply these together. One way would be to use that box method, which we're going to need to use in the numerator anyhow, so I'll show you how to do that in just a minute. But that'd be the longer way. The faster way would be to multiply the first terms and the last terms. So negative 3 times negative 3 would be a positive 9. And 2i times negative 2i would be negative 4i squared, which I squared is negative 1. So negative 4 times negative 1 would be a positive 4. So we'd have 13 in our denominator. Remember, that was the second way. That's a fast way to do it, but it's not the fastest. The fastest way to do this would just be to square the negative 3 and square the 2 and add those together. So negative 3 squared is 9, plus 4, bam, I got 13. Okay, so that's the fastest way. But let's look at the numerator. So the numerator, I'm actually going to do that using this box method. So I would have 6 minus I on one side and negative 3 minus 2i on the other side. All right, so when I multiply those together, negative 3 times 6, that's negative 18. This would be positive 3i. This would be negative 12i. And this would be a positive 2i squared. But remember, I squared is negative 1, so this is really negative 2. So 18 minus 2 is negative 20. And then 3i minus 12i would be negative 9i. Now, they do say to write this in a plus bi form. It's not as nice, though, as our previous example, if you saw the video for 34. When this breaks apart, we have negative 20 over 13. We could just say minus 9i over 13. That's an a plus bi form, and neither one of those can be reduced. So that would be your final answer for number 35. All right, let's look at 36. So 36, we're asked to find the degree of the polynomial. Now, first off, before we find the degree, you always want to make sure it's in standard form. How do we know? Well, you want to make sure that you look at those exponents, and you want to make sure it's starting with the largest exponent. So 9 is the largest exponent, and then it goes 6, 3, and 2. So that is in standard form. So the degree is the largest exponent. So the degree for this would just be 9, not 5x to the 9. It would just be 9. The leading coefficient would be the term, or the coefficient of the term with the degrees. So this would be, the leading coefficient just be 5, not 5x, not 5x to the 9th, just 5. The coefficient of x to the 4th. Ooh, there is no x to the 4th. So that means the coefficient for that would be 0, because 0x to the 4th would be nothing. The constant term is whatever we have at the end here without a variable. So here it's not just 17, it's a negative 17. And the number of zeros it must have at least, since the degree is 9, it must have at least, or must have 9 zeros then. All right. So let's look at this one. So 63, it says, how many real zeros does f seem to have? Okay, so the number of real zeros, we're going to use the horizontal line test, the graph wiggliness theorem. And, oh, actually, you know what? No, it's asking real zeros, not the total number of zeros, the real zeros. The real zeros are going to be your x-intercepts. And so there's 3 real zeros there. So that's what we would say there. Now, if it asks what's the smallest degree that it must have, that's where we use that horizontal line. I wasn't reading the question carefully. And then that in this situation, it looks like the most number of points that a line would cross would be 3. So it looks like it would have to be a degree of 3. All right. Lastly, let's look at number 66. So it says above here we have a graph of a function with various x coordinates. Describe all intervals in which the values are positive. So the intervals where it's positive. Okay, so I'm going to use my highlighter here. Positive here. So we're looking at where the y value is positive, and it's positive where I just highlighted. So we would say from the interval from a to c, it's positive. On the interval from e to g, it's positive. And on the interval from, looks like I to infinity, it's positive. Now, we would use parentheses there because, remember, on the x-axis there, it's neither positive nor negative. So we would just use parentheses. So where is the graph negative? So that would be below the x-axis is where the values would be negative. So we're going to describe that by saying from negative infinity to a, it's negative. From c to e, it's negative. And from g to I, it's negative. And where is it increasing? Well, we read a graph from left to right. So we would say it's increasing up until we get to b, and then it would be decreasing. And then it's going to be, move up a little bit here, then it's going to be increasing up to f, and then it's going to be decreasing until we hit g, and then it's going to be increasing. So the spots where it's increasing at are these intervals. Okay, so from negative infinity, so along the x-axis, we describe it from the, even though we're looking at the graph, basically we're looking at the y values where it's increasing and decreasing, but we describe it with the x values. So we would say that from negative infinity until we get to b is where the graph is increasing. And then at b, it's neither increasing nor decreasing, so we can just use parentheses there. And then from d to f, it's increasing. And from h to infinity, it's increasing. And where is it decreasing at? Well, it's decreasing at the other values. So those would be just those two sections there. So from b to d, it's decreasing. Oops. So from b to d, it's decreasing. And then from f to h, it's decreasing there as well. So that's how you can describe whether it's increasing or decreasing or positive or negative. So that goes through all of the questions in the review. So hopefully that answers all your questions. And so if there was anything in here that you still don't quite understand, please make sure that you jump into my Meet during the class period or schedule time with me for my office hours so we can make sure you get those questions answered.